All right. Hello everyone. So today will be the first Python workshop of the DSI. I'm really excited that everyone showed up. And yeah, before we get started, I really appreciate everyone could go down to the description and fill out the link. Basically lets us know that who's here, who's not here, get us a better idea of who's coming to our events. Also, I really appreciate it if you guys would like post in chat of your experience with Python. Is this your first time? Um, have you done it before? And also, it'd be great if I knew, if this is your first workshop at DSI. And yeah, we'll give it a few minutes before we start. But yeah, is everyone set up with Python as well? There's many different IDEs or like ways you can run Python. And yeah, I really appreciate it if saw some feedback today. And if you need help setting on Python, I have some good suggestions as well. So we'll give it a minute, but while we get started, um, yeah, let's get started, I guess. So, one second while this connects. Trust. All right, so Python 0. And yeah, so just get started here. So Python, or at DSI, like I said at the top, please sign in if you haven't already. Um, and yeah, so DSI is a multi-interdisciplinary student organization that is dedicated to promoting data science at UF. Yeah, so we teach skills that we think are prudent to data science. So, things like Python, machine learning, um, and yeah, all those kind of things. Um, yeah, and also other things like SQL and GitHub that are across other professions as well. Um, so yeah. So has anyone typed in chat yet? Sorry. Um, all right, cool. One second while we get started. All right, so I don't see any question in chat, so I'm gonna go ahead and get started. So Python is a really good language. It's like personally my favorite. It's really straightforward and simple. It's like a good, easy to use language that's like object oriented. So if you don't know what that means, don't worry about it. But if you do, it means it's like you can use classes. Basically, you can encapsulate like complex variables into like a single thing. And then yeah, a lot of things are used with Python nowadays, whether it's backend of websites, whether it's like scripts, whether it's for data science, software engineering. Everyone uses it nowadays. So I think it'd be very good for everyone to learn it. And this will just kind of introduce you to the basics of it. So we're not going to anything crazy in depth today. At the end, we'll do a little bit of data science introduction, but today will mostly just be about basics. So let's go ahead and get started. So the first thing is that we'll talk about basic stuff, right? So the first thing is like adding, subtracting, right? So if you do like 1 plus 2, and if you press the Shift Enter, one sec while my thing connects, it will return answer. Really straightforward. You can do, adding, subtracting, really straightforward. Same thing with multiplication and division. So if you do like 3 times 4, you get 12. Really straightforward. And then same with division. So if I do 3 divided by 4, I get 0.75. So really straightforward. One thing I will say is say you do two operations, right? So say you do 3/4, you want to find that, or 3 divided by 4, and then you want to say do, 3 times 4. What you'll notice is it always does it at last, only prints the last operation, right? And this is like a unique thing about Jupyter Notebooks. So if you want to do the first one, what you can do is you can use the print command, and you put it in parentheses because it's a function. If you do both, it will print both. So you see here we got the first one, 0.75, and then 12, right? And you can do multiple on the same line, right? So if you want, 0.75 and 12, you can just put them in the same line. There you go, right? One other thing to know about division is that when you do this 3 divided by 4, it gives you always like a decimal number, as you see here. But if you do, this is like something unique, but if you do this with a double, so 3, let's do this, 4 divided, like 2 divides by 3, what it does is that this just returns an integer part. So in reality, this turns 1 and 1/3 or 1.33, but this will just return, um, sorry, the integer part. So this is like one thing, say you want, instead of having to cast, like maybe in other languages where basically you have like floating point turn to integer, you can automatically do with this. What other thing is that obviously this also works with things like floating point number, or not floating point, with things like parentheses. So if you do like, if you do like, I don't know, 2 times 3 and then divide by 4, this also works. So, it works with order of operations as well. And yeah, so that's basics of multiplication and division. Excuse me. Next thing is exponentiation or exponents. So normally I think most people probably assume it's this. Whoops. 3 raised to the 6th, right? But unfortunately, if you do that, it's not going to get the right answer. And what this is doing is something else. So in Python, the way you do exponents is it's double multiply. So then you get the large answer, right? So yeah, so it's a little different, something you have to know. It's different about Python than say maybe like MATLAB or something. You can also do this, for example, if you do like 16 raised to maybe the 1/2 power. You get 4.0. So you can do the same kind of things. And later we'll talk about, like, hey, like maybe I just want to have a square root function. So there's definitely things that we can do in Python. So this is just a proof of concept. So do you have any questions before we move on to the next stage? Talking about variable declaration. My screen is a bit blurry. Okay, let me try zooming in then. View, appearance, how do you zoom in? I think it's like this. Alright, let me know. Is it not blurry anymore? Before I move on, I don't want to. Yeah. Also, it might be the settings on your YouTube. So if it's, 360p, it might be blurry. So I might want to bump up your settings. That's better. Is it still kind of blurry or? Okay, perfect. Alrighty. And people who are just joining us, I would appreciate if you could fill out the sign-in information stuff in the description. Alright, next thing we're talking about is declaration. So obviously you don't want to only just like perform calculations, you want to do complex functions that usually require you to assign variables, right? So variables can be alphanumeric names beginning with underscore letters. Variable types do not have to be declared and they are inferred. That's one big difference between Python and other languages. For example, say you were in like Java or C or something, you have to do like int I equals 0. But if you do this, it'll say like, hey, that's not right. So what you actually do is you just say I equals, I don't know, 13, right? And that's what works. So what this does is it automatically determines what type this should be. So, one way we can check the type is if you do like a print statement with a type of I, you'll return and say, okay, hey, this is a class of int. So basically telling you, hey, it's integer. And yeah, that's pretty straightforward. That's the nice thing about Python. You never have to declare the types of your variables. Same thing with floating point numbers. So if you do like, like j equals 4.5, and if you do print type j, yet again we'll do float, right? So one thing I will say that's unique is that, so say you do this, right? 1, as we know, this will return a class of an integer, but say we do 1.0. Now, you might think like, hey, this is, it's still 1, it should be integer, but actually since you put the .0 after it, it'll become a float. So yeah, that's something to keep in mind. Also you could like switch between types if you really want to. So say you had like 1 and you want to be a decimal number or a float as they call it, you could do something like, this is called casting. And then yeah, then it'll become a float. So these are all just ways, but in reality, nice thing about Python is that it does it for you, so don't have to worry about that. Okay, next thing is strings. So strings, similar to other things, you just type it with quotations or double quotes. So, or yeah. So if you name it first name, like F name equals, Simon, and maybe, or I can do like last name equals Frank, right? And I can print both of them. And yeah, they'll print them. Really straightforward. We can check the type of it. So print type. Again, both strings, right? So straightforward. And yeah, any questions before we move on? Let me look at the questions really quick. Will this video be posted on this page later as well for those of us who have to leave? Yes. So after this live stream is done, I'll hopefully be able to post this directly to YouTube channels. So if you want to go back and rewatch something, or say you have to head out, you can definitely go see that in the future. Yeah. So yeah, don't worry about that. So if you leave, don't feel bad at all. All right. So next thing is going to be importing, right? So up here we talked about, hey, like that's pretty annoying. I don't want to have to write exponent of 1/2 to square root something, right? It would be really nice if we could, import some library that doesn't, has a square root function, right? Because natively Python doesn't have it, right? So if I go back up to here and do, well, I think it maybe does. Let's check. sqrt 16. Maybe not. I don't know. Maybe there is, maybe there isn't. But regardless, we can import one, right? And there's a lot of other functions that we want to import, right? So say we want to import math library, which will definitely have the square root function. We can just do the import math. And what this does now is that we're allowed to call any of the functions within math, right? But if, for example, say we do something like, within the math function, we know there's this function called cosine. We do want to find the cosine of 0. It will break because it says, hey, I don't know what cosine is. But so what you have to do is you have to do with the math first, like do the namespace and then the function. So if you go down here and do math, oops, can't type. You will see it comes back with the answer. So yeah, if you just do with this kind of imports, it will bring in the entire math library, and then you have to do math and then the function name. That's one way to do it, right? Which is totally valid. Another way to do it though is you can import the function itself and then directly call cosine. So the way you do that is you say from math import cosine, right? Now we can directly call it, right? So if you say, sorry, I'm trying to make sure I'm going. So yeah, so now if you directly call, cosine of 0, it'll, return the answer. So thing to know here is if you do import, you're bringing in the namespace or like the ability to call functions from that library, and then you have to use math dot the function name to call it, or you can do the from the library and then import that certain function, and you can directly call it. This might seem a little confusing in the beginning, but as time goes on, you'll understand it better. All right, let's see if any questions. All right, I don't see any more, so I guess I'll move on. All right, so also like say like, hey, like we want to import everything, right? So there's lots of functions within math. You can do math dot. You see there's a bunch of functions, right? And say we want to use them all, or like say, hey, let's not, I don't want to have to manually do a from math import and then the function name, right? What you can do is you can use this syntax. So you can do from math, so you get the same thing as before, but then you do the star. So what the star does is it basically says select all. So now you have all access to all the different math functions. So if you do like pi, it will return you the value of pi. If you do, I don't know, sine of pi, okay, okay, it should, this is essentially 0. This is a result of representations of floating point numbers. But basically it's just a 0, right? Maybe we'll do this. Or let's do this. There you go, -1, right? So you can now you have access to all the different functions within math. I will say that one thing about this that is bad is that say you have this, math's a pretty, even has a lot of functions, it's relatively small. The code is like not very verbose because a lot of times it's simple functions. But say you have some like huge library, tons of space. If you import all, it'll take up a bunch of your like memory space in your RAM, but also it might take a while. So, for something like math, it's totally fine to do that. But if you're maybe importing some like much larger, complexer library, you probably don't import everything. You probably just want to select like, hey, let's only do like cosine, sine, pi, something along those lines. And yeah. All right, let's see if there's any questions. Nope. All right, so we talked about how to declare strings up here, but now let's say like, hey, say we have some really long string that we're given and we want to, get parts out, right? So say we have like a string called like, my string, can't type, and it says something like, uh, go Gators, on Gators, get up and go. Right, and so this is like the chant you see here at football games a lot of time. And yeah, so say the string, right? And say you only want to get basically parts of the string, right? So say you only want to select like the Go Gators, right? Or say you want to select everything maybe after Go Gators, right? And so what you can do is that you can it's called indexing, right? So basically you can take certain parts by saying I want this part of the string, this part of the string. This is a really important thing in Python. You'll see this idea not only in strings, but in arrays and many other structures in Python. So yeah, so Python's a zero index language, which means that, typically I think non-programmers think like this is the first position, this G, but in reality this is the 0th position. So this goes, 0, whoops, 0, 1, 2, 3, 4, 5, 6, 7, 8, right? So it's something a little, you have to get used to it, but once you get hang of it, it's not that bad. And yeah, so what you can do is you can use this notation where if you do like my string, whoops, and you use the brackets, and then you do like 9, whoops. What this does is that it basically gets all the characters before 9. And so, if you remember, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, we should just get Go Gators, right? Because the ninth is a comma. Also realize the spaces are also values. So if you do this, we could Go Gators, right? Perfect. So say you want the characters after the 27th, right? Same concept. So if we do my string, and this is like, sorry, after, right? So this is so after you do, 27 basically and beyond, right? So basically what this is saying is that I want all the way up to the 9th. It's saying 27th and beyond. So if we do this, we get up and go, right? So it's looking good. You can also do both, right? So say you only want the middle part, come on Gators, right? So we can do my string. So we get the variable and then we index into it and we say, all right, we know this is the 9th, 10th, 11th, right? So we want the starting at the 11th and then we want to go up to this one, right? So if we know this one's 27 right here, 26, 25. Oops. All right, so there you go. So kind of a recap here. This notation basically gets up to 9. This is after 9. This is selecting a range of values. And yeah, basically you can think of like this colon as like all remaining, kind of is the way I think about it. And yeah, any questions? All right, cool. Yeah, guys, if you have any questions, feel free to put them in chat. Alright, so negative numbers. Alright, so hello? Alright, sorry, my mic died. You can also do stuff like negative indexing into strings. So say you don't necessarily know what this index is, it'd be hard to go and say like, okay, like count each one. But what you can do is that you can go like basically backwards around it, which seems kind of confusing at first. But you'll get we'll show you. So my string, and then you can do from -3 to -1. So basically what this did is it says, okay, I want -3. So it says negative 1, -2, -3. So you start here and then you go to -1. So, and then, yeah, so it's 0, -1. So you get these three is y. Um, and yeah, that's kind of, you can do negative as well. Um, you could also like technically reverse it by going from like, I think like this. Oh, and it's the same thing. Sorry, that's the same thing. If you do, I don't know. Whoops. Anyways, yeah, that's you can do negative indexing as well. All right. So in addition to indexing, you can also do some other operations on strings. You can also like find stuff within it. So if you do like my string dot find gators, what this will do is that this will return the index where this is first found. So if we go back up here, so this is 0, 1, 2, 3. So you see here the first gators is found here and it's found the third index. That's what the find function does. This might be helpful if you're trying to um, like look at different sentences or strings and trying to find like certain values from it. It also like if it doesn't find anything, it will turn -1. We can show that here. So like my string dot find, and let's say Seminoles, and it'll turn -1. So if it's not in there, it'll turn -1. What also it can do is that it can fully capitalize and like make every single letter capitalized or lowercase. So if you do like this, is everything capitalized, and the same thing. I do all lower, right? So if before there's capital G and capital G's and C's, if you do like this, print both out. Oops. Alrighty. Another thing you can do is this function called split, and what this does is that it will basically like take your string and split based on a character. So for example, if you do like my string dot split on something like, say let's do a comma, what it'll do is that it'll basically create an array or like a list of all the different like parts of the string based on the thing you split upon. So if you see here, it goes all the way up to it, takes that part, and then it removes the comma, and then it goes to the next part, chops it right here, and then take the next part. So that's a nice thing about split. So say you could also do something like spaces, so you won't get like every word within a sentence. If you do space, you can get individual words in a sentence like that as well. And yeah, that sometimes is very useful. Sorry, I was looking. Yeah. Also think natively, if you just do this without any functions or without any parameters, it does the same thing, right? And it will actually remove. Oh no, they're still here. Yeah. So this is actually equal to that, or you can, yeah. So, and that is it for split. Let me look if any other questions. Nope. All right. next part. All right, join. So say you have two separate strings and you want to join them together. You can call it join. So say you have you do like my string dot join dot join, and let's say like I am a big fan, or let's just I love the Gators. Whoops, sorry. I think I. Oh, so this what happened here is that this was already split among. We have to like here. Sorry. What we're gonna do is we're just gonna rerun it so that it's back to the original state. And then if we do join, whoops. Okay, so sorry. It's not the way you do it. Sorry. So the way you can do it is if you do like if you do this, and then you do join go. There you go. Okay, so basically what this does is that this is the part that how it's gonna like join the two together. So see how it's joining by a space, and then these are things it's gonna join. So yeah, not exactly the way I was thinking about it earlier, but yeah, this is the correct way. So basically you start off with what you want to join your two things with. So you can also do it like three. So you could do like go Gators. Maybe, I don't know. Like this. Go Gators. If you do something, if you instead of a space, you put like underscore. Yep. So pretty straightforward. And we're not gonna go through all of them today. There's a ton. So if you go to this website, you can also see a bunch of them. So, and also like another way you can do it is if you do like my string and then you do dot, you can see a lot of them, right? So you can do like I don't know. You can do replace, like say you want to replace a character or something like that. All kinds of stuff. So I can go over them all, but if you Google them, like Google your problem, they're probably gonna answer. All right, next thing. So we talked about lists, or we talked about strings a bunch, and let's talk about lists. Um, so Python is nice, is that you can like increase the size or decrease the size of your list without re-declaring it. So say you have a list of 5 items called like my list, and you use angle brackets for it. So you can call like 1, 2, 3, and you can mix type. So you can do like 4, and then 5.0, right? And this will work. This will not work in many other languages, but this doesn't work. This does work in Python, right? So if you want to add to a list to the end of it, you can use the append method. So if you do, say you want to add 6 to the end, and we can print a list and see it. Whoops. Now we have this, so we can see that we added it. Hey, and also like say like, hey, we want to. Another thing we can do is like if we want to replace this value at a certain point index, or we want to replace a value in an array with a different value, we can do the insert. So if we do my list.insert 6 with the value of 7. Whoops. And if we do print my list. Oh, sorry, we have to. Oh, yeah. So if we do. Yeah. Okay, so there you go. So we basically inserted at the index 6. Remember, this is 0, 1, 2, 3, 4, 5, 6. Even though the number, indexes because it's 0 indexed. And yeah, so with the 6 index, which we haven't declared yet, we're going to add the value of 7. Yeah, the next thing we can do is we can remove like values in the array based on if they match or not. So if we do mylist dot remove, and let's say we want to remove all the ones that match 4, we do mylist. I'll do print. Just as X is not in the list. Oops, oh, because we have extra space here. That will be an issue. Yep, alright, so there we go. And yeah. And there we go, okay? So, next thing we can do, oh yeah, so one thing I will say is that, oh sorry, yeah. So okay, so what this happens here is that like, you don't have to do something like this. Because you don't have to basically reassign my list with a new list. What this does is that automatically updates the list. So yeah, that's what this is saying. You don't have to basically do this. You can just have this. This automatically updates the list here. Yes. Sorry, one second. Another thing we can do is that we can get the length of it. So say we have, or like the number of elements in it, right? So if we do print the length of my list, it will show it, right? So we can say, okay, 1, 2, 3, 4, 5, 6 things in the list. Another thing we can do is we can sort the list. So let's create unsorted list. So let's take like a new underscore list equal, let's just say 5, 6, 11, 1, 0, 23, right? And then let's do new list dot sort. Whoops. Let's print the new list. It sorts it. So if you have something that is sortable, it will do it automatically for you. So you don't have to create an algorithm to sort. It just it has a built-in one for you. If you want to learn how it does it, I would look online. I don't really want to go into depth about that today. If you want after the workshop, we can talk about it. I can show you some resources on how to learn more about it. Another thing we can do is that we can reverse the list. So say we want to take this list, instead of putting it in ascending order, we want to put it in descending order. What we can do is we can do new underscore list dot reverse, and then we can like print the new list. There you go. So reverse it. So yeah, that's an easy way to do it. And like just like strings, there's tons of methods for lists. And if you want to, look at more of it, there's this link you can check out. Okay, so now we got some basic stuff down, some like data structures of, lists, of things like strings, and we know how to declare variables and stuff like that. We also may want to do some conditionals. So basically say like, hey, if this happens, then do this. Elsewise, do this. So this is called conditionals. So say it's like if okay, let's declare some variables. So say we have a variables called like, let's say x equals to 1, y equals 2, right? And we say, so that's how we do it. So let's say if x is greater than y, and that's how you do it. So then you put the colon here. You can also put this in parentheses if you want. And let's say we'll print something. So let's say print x is greater than y, right? And then we'll say, hey, what if it isn't, right? So else we'll say, oops, print x is less than or equal to y. Yeah, so one thing I want to say here is that you have to do, like, and so in Python, there's no colons, semicolons, in that denotes like syntax. So what you have to do is you have to make sure you have white space. So white space is very important in Python. If you don't have it, sorry, one second. If you don't have it, it will run. So if you do this, yeah, so it'll run, right? So you can change the numbers as well, and it'll work, right? And yeah, so uh, yeah, we can also do something called like an Elsif. So Elsif x is, let's say, equal to y. Print x is equal to y. Yeah, okay, so I guess you go this. So, usually we say things are equal, we only keep one of them, but when we do conditionals, we have to do two of them, which basically this um, makes it return true or positive. So if you know here, this either returns true or positive, and then the same thing if you want to do, hey, if we do this, this is like assignment, while this returns a true or positive. So that's one thing you have to remember. Um, Sorry. And then yeah, so if we do this and we had, oops. Oh, sorry, it's L. Yeah, sorry, it's not Elsif, it's Elif. Just syntax things. But yeah, so this is how you do conditional. So not only can you do this, but you can also do, you know, like nested conditionals. So if you do something like, if x is greater than or equal to 0, like print x is greater than 0. Um, so 4. Yep. So you can do nested one thing. You can kind of see how this would keep moving along. All right, so that's kind of conditionals. This is basically a way to like branch your code. So if you want, based on the results, it can go either one way or another way, and kind of go from there. These are really important for coding in general. All right, so the next thing we have to do is looping, right? So say we want to have the same task repeated over and over again, right? So say we want to do something where it's, say you want to count, like add the numbers of 10, right? It'd be really bad if you were to do something like, like 1 plus 2 plus 3 plus 4 plus 5, that'd be kind of stupid. So the smarter way to do it is to use loops. And basically what loops does is that it does the same task over and over again. Um, it does the same task over and over again for designated time. So what you can do is you can say for I and I'll explain what this means in a second. For I in range of 1 to 10, let's just call this, we'll call variable called sum. Right? Yeah, let's say sum, and let's say, sum plus equals I, and then okay, so let me explain. So what this does is that it initializes a variable to the sum. So you start off with 0, and then what it does is say, okay, for I in a range of 1 to 10. So basically what it does is that I is going to be the values uh, 1 to 10. So first off, I will be 1, and then it will add what this does, and then it'll add this value to sum, right? So plus equals, what it does is it takes sum and it adds the value to it, right? So it will add 1, then it will, once it's done, this will be updated 2, it'll add 2, and yeah. So it goes like that. So here, also what I'll do is do this. I. So as you can see, yeah, so you see here, I is 1, it adds the sum, then I is 2, 3, 4, 5, 6, 7, 8, 9, 10, it keeps adding the sum and eventually gets the answer. So you see here, this is really useful for lots of operations, right? And so the hardest part of it is like basically how you're looping, right? So you always need the for. For basically lets you know Python that you're going to be looping. The I is a variable that's going to be changing each time a loop finishes. And then this part is called the iterator. So basically what this says is like it's telling you um, like what values I is going to be. And yeah. Another way you can do it is like say you want to add all the even numbers up to like say 20, you could do for a range of 2, and then you want to increase by 2 up to 20. Oops, what did I do wrong? I think I did it backwards actually. Yeah, there you go. Sorry. So you see here, it starts at 2 and then it increases by 2 each time until it gets to until it keeps doing it until it's less than 20. Yeah. So and that's kind of this step down here. So we can here I'll put this down here and then we'll just keep this example. Yep. All right. So that's kind of loops in a nutshell. And yeah. So there's lots of ways you can do this. Yeah, another way you can do this is like say you have like some string. Another way you can do it instead of iterating over like this range, you also do it over like a set of strings, right? So, so say you have some like for I, and this isn't to be I. Let's just okay this. Let's just make this string, and we can create a list again. So let's say go gators. Let's do one more. I don't know, UF, sure. And you need the semicolon here, and you say print string. This will also work. So what this does is that string is initially set to go, it prints it, and then once it is done with its block, it goes back up the top, reassigns string to gators, and then it keeps doing that, and then prints it, prints gators, finishes block, so UF goes into string and keeps going over again. So as you can see, there's many ways that you can do this. And yeah. One other thing I will say is there's also this thing called like a while loop. So you have this variable called like yeah, let me write it real quick. So it's like int I, let's just call var equals 10. You can say while var is greater than 0. What we'll do is that we'll print var, and then we'll say var minus equals 1. Okay, so what this do, we're starting off with 10. And then we're saying while this variable is greater than 0, we want to print out the variable and then subtract 1 from it. So if we run it, we get this, right? So the basic difference between these two is that this one loops as long as this condition is true, while for loops, like while loops do that based on conditions, while for loops do it based off some like predetermined list or set. And yeah, any questions? I'm going to stop for a second and see if anyone has any questions. And yeah, we'll wait a minute. Okay, yeah, so here's a question. So range doesn't include 10, right? Yeah, so the way range works, so if I do range, let's say 0 to 10, right? Oops, sorry, so we have to do list. List range. Sorry. Yeah, so see here it doesn't include 10. So what this is it goes up to 10, right? So it always starts with inclusive and ends with exclusive. So if you wanted to include 10, you'd have to do maybe like 10 plus 1 or 11 would obviously work. And yeah, that'd be it. Yeah, good question. Also, for example, you could just do this. Just do 11, and that would then start with 0 and then go up to 10 as well. Yep, good question. Any other questions about like how to use for loops, while loops, and that kind of stuff? Those are really important. Alrighty, cool. For anyone who's joining us late, I really appreciate if you can go into the description and log in through that, or sign in through the link provided. Really appreciate it so we can tell everyone who came tonight. Alrighty, that's a good question. Alright, so now into I would say, probably the meat of Python, right? So a lot of times you maybe have some type of code that you don't you have to calculate the same thing over and over again, or you don't want to be copying and pasting your code within the same notebook. That'd be kind of a waste. So the way you can do that is that you can write functions, right? So say you want to define a function that basically, like, if you give it a number, it tells you if it's greater than 0 or not, right? So so define is the syntax for letting you know they're going to define a function, and then we'll give the name of the function. If it goes something like greater than 0, and then here what we do is that we put the parentheses, and inside we put the input, right? So maybe this is like a number, right? We put the colon, and then yet again, just like for loops or conditionals, we need this spacing, the white space in front of it. And then we say like if number is greater than 0, maybe we will print a statement like, this number is larger than 0, right? And yeah, sorry. So if we want to call it, the way we can do that is we can just like this, greater than 0, and then let's put a number, right? So maybe put 1. All right, so it works, right? So you can define functions in this way. Obviously, these can get much more complex. So maybe one that says like football players, right? So yet again, define our maybe let's say UF football, and we have to get the name. Um, maybe like the player name, team underscore name, and then number, right? So say we get those three things, and now what we can do is that we can print, a whole string. So what we can do is we can say like, we can have printed in a string, right? So we can say player name. So basically what it does is it takes an input and puts it in here, player name. And so this, yeah, so let me write this down first. Plays for. So let me write this out first, and then we'll explain. Alright, so what this does is that it takes a player name, so whatever you input it, and then it basically combines the two strings. So if this is say like, hey, this is Simon, and then I'll say plays for UF and is a number blank. So basically what it does is that it combines like all these strings into one string. So if we do something, we run this, define the function, we say UF football Simon UF, Sorry, my headphones keep dying. And pipe number 65. Oops, what happened here? Number is not defined. Oh, because I misspelled it up here. So, okay, Simon plays. Let me put space here. There you go. So Simon plays for UF and is, I can't spell apparently today. So yeah, so we can all kinds of fun stuff. So this is an example of string concatenation. So what we see what this does is that you take your strings and combine them together. One thing that you have to be careful with is say you didn't make this a string, you just put the number itself. You did this, it would say like, hey, like I can't combine, like I don't know how to add a string plus a number. So what you can do is like, if you remember at the very beginning of the class, we talked about converting, like between different types. You can also do that with, um, like from numbers to letters. What you can do is to convert you do str. Oops, one too many. And I'll do the same thing, right? So sometimes you have to be careful, even though Python automatically decides what type it is. You still have to make sure that like types can combine. So for example, you can add numbers together, but you can't add like a word plus a number and expect Python to know how to um, do it. Any questions on that? All right. If not, we'll also do so say for example, you want to do something similar, but almost you always want the answer to be say you don't want always have to input your answers, right? Or input your uh, parameters into your input. Say you want some like default ones, right? So what you can do that is you could say like define um, add one function where you have your x. Let's say added sorry. So say you want your function to take x and add some value to it, right? So you want to say um, so say you want to say print x plus some added value, right? Which is whatever it is, yeah. So if you do like add value 1 comma 3, it'll give you the answer, right? But say you don't want to have to always supply through. What you can do is you can give it default parameters by doing this. And what it'll do is that even if you don't supply the parameters in the function, it'll still know what it is. So if you see here, so 3, say I just want to add 1, it'll automatically do it. So you can do this kind of way that it'll automatically do it. And also you can replace it. Say it's add 1, but you want to add, let's say 10. You could say, 10. It'll still work. So that's one way you can do default parameters. Yeah, also you can do it like this as well. So you can do like added, and that'll do the same thing. One thing you have to be careful with is like say you don't put them in the correct order, right? Like for example, say you do something like this. What this will do is this will take x as added value. This will take x as the let's take 10 as an x and 1 as added value. So if you want to make sure, you can do it like this and make sure, you don't have to do the exact order if you do it this way. So, whoops, okay, no, sorry, you do it x equals. There you go. So yeah, if you do them out of order, you have to give the variable name and then equal to for it to work. All right, and yeah, so this is kind of supplying all the arguments. Oh yeah, and I just realized that I'm not exactly following the instructor version, so if you're trying to follow along with that, I'm sorry, but I'm trying to create my own functions. But if you want to like look through the exactly how to do it, there's also an instructor version that has all these answers for you. So if you didn't necessarily code with us today, you can give all these answers too. They'll have all the answers here for you as well. So, yep. I think we covered, yeah, we covered this right up here. We covered calling with arguments instead of positional by using this. Basically, just saying is that like if we do something like this, we're assigning arguments positionally, and if we're doing it this way, we're already assigning arguments. We're assigning parameters based on arguments. So only difference. Either way works. All right. So say you want, say you don't want your functions just to print values, right? Say you want them to return something, which is very reasonable, happens all the time. You can define functions to return values by using the return. So if you say define sum where you have A and B, what you can do is you can use the return syntax, and then let's do A plus B, and then you can, and that's how you do it. So say you wanted to have source and variable, so let's say X equals sum A comma B. Whoops, yeah, not 1 comma 3 print. There you go. So basically what it does is that you input 1 and 3 into your sum function, it returns 4, and then we print 4. So that is it for terms of basic Python, fundamentals. We're about to move into the data science tutorial of starting again some basics of data science in Python. I'm going to stop for a second. If you want any questions or yeah, and we'll get started in a second. Let me look in chat. Alrighty, I think we'll go ahead and get started again. So one nice thing I really like about Python is that it's like integration with data science tools. So, and yeah, so that's how we do it. So let's go ahead and get started. So one of the main functions, or sorry, one of the main libraries in Python for data science is this library called Pandas. And yeah, and also, yeah, so we'll go ahead and start. And that's a really great way to like import data sets. So I believe we have, sorry, make sure we're going the right one. There's a data set right here, breast cancer in Wisconsin, where it has a bunch of values. Okay, we'll do this. We'll do this data set, global health data set. Actually, no, let's do the one in the instructor. Sorry. Okay, so before we get started on that, let's import it. So what we do is we do import pandas as PD. Okay, so we haven't talked about as before. So as we talked about with the math function at the very beginning, import basically brings pandas into your Python notebook to be called. And so typically we have to say like pandas dot whatever to call the functions, but when we use the as PD, what this basically does is it renames pandas to be PD. So instead of writing pandas every time, we're just going to use PD. This saves, I don't know, I personally do this a lot to save time. I think it's just generally kind of like the norm. And yeah, so let me get the data set because I think it's just off a online repo. Yep. Okay. Oops. Okay, so then what we can do is that if we do this function, so PD, so this is really, you can also write pandas here if you don't have the as, read CSV, and then it goes to this online website and then gets the data. And then it puts it all into the salary. And then what the nice thing about pandas is that it puts in this really nice data frame. So if we do, print salary data, oops, sorry, we shouldn't do Oh, HTTP error. Not found. One second. Let me go to this link and see if it's. Yeah, okay, that website's down, so they no longer work. Okay, so we'll use a different data set. So we'll use a global health data one. So this one, yeah, we'll use this one. So what you can do is if you have it stored locally on your computer, what you can do is you can do dot slash, which basically says your current directory, and then you say global, just name of the file. File not found. It's interesting. One second while I think why it's not working. Did I spell it wrong? Um, why is this not working? Alright, one second, let me try to figure this out. Sorry guys, one second. Wait, sorry. Okay, so we're in the right place. Sorry guys, one second, I don't know why. Oh, sorry. So we're in the Python directory, we have to go out one. Yeah. Sorry. So yeah, so what we have to do here is we do get the current directory, we go back one and then go. Yeah, okay. Um, okay, yeah. Okay, so sorry guys, so let me explain this. So basically what this does is that you're in the current directory, which is in Python, and then since this data is outside this folder, we have to go back one, which uses dot dot, and then once you're outside, then you can get the global health data. Um, yeah, so let me clean this up for a second. Okay, so now we have this thing, we have this basically data in the global, in this variable called health, and if you notice here, it's really nice. So each row is a sample, and each column is a variable with, a column name. So if you number of new reported cases of human, African, I don't even want to say that word, I'm embarrassed, that disease, all right? So now that we have this data in this thing, we can also do the dot head, so we'll give the first couple rows. So if we get the first 5 rows, we can see all of its attributes, right? So we can see yellow fever, number of reported cases, all that kind of stuff. Any questions about this? Sorry about the delay. All right. So since it doesn't work, I'll do some other stuff. So let's example. Let's look at the number of reported cases of cholera, right? So if I do, oops, sorry. So let's look at number of cases for cholera. So say we do like so we do their salary data, and then we say let's get the column that says number for cases of cholera. We use again, just like we do with lists, we can use the brackets to get index into things. And this will give us the list of all the things. And then we can use the dot describe method. And this will give us all these type of sample statistics. So for example, like the number that are not NA, the mean value of it, standard deviation, min, max, and that's like 25th quartile, 50th quartile, and then the 75th quartile. And yeah, so that's a way you can look. This is a way that you index into certain columns, and then the describe will give you some basic sample statistics. Yep. So you can also do something like, say you want the same column, and say you just want, the mean. You can do that with just the mean, and it'll give you some really, long number, and then you can do the dot round, to 3, and this will round it maybe to the number, round your decimal to 3 decimal points. Yeah, you can see this kind of here, dot mean dot round. Yep. Alright, so say you also want to find the unique values in a column. So let's just go back to our head. So let's do health data dot head. And say you want to find all the unique values, right? So, I don't know. Let's find the number of unique values in the same thing, number of cases in cholera. So if you do the same thing, health data, and you go to the certain column, and then you do unique, this will return all the unique values. And yep, that's that. So we can also get the length of this if you remember from before. If you used the length, we see there's 128 unique values. Alright, so this is called data frame, and there's a lot of nice things you can do with it. As you see, there's functions built into the columns, like unique or describe. But there's also some other things you can do. You can also take, and besides just columns, you can do the entire thing. So if you do like salary data dot describe, instead of doing it just in one column at a time, you can do the entire data frame. You can get it for each one, right? So you can get the mean number of cases of cholera, any of these. So tuberculosis looks like there is, what is that, about 30,000, I think? Am I doing the math right? Yeah, so there's a lot of things you can do with it. Pandas is pretty nice. It's easy to manipulate. And yeah, so we'll go to that. We'll go more into pandas and all of its functionality into Python 1. We'll stop pandas for today. Another thing we can do is that we can plot data in Python. So, a lot of times when you're doing data analysis, you want to make sure, or you want to see like, hey, I have some plot. I want to see how these two things are related. Maybe look at correlations, or yeah, there's a lot of reasons why you need plots. So Python has some built-in libraries for that. So if you import matplotlib, that's one really big popular library. Another one is Seaborn. Seaborn's probably a little easier to use, but matplotlib is probably a bit harder, but you have more customization on it. And yeah, that's how you import to libraries. This is just saying the style. Um, you don't have to do this by no means, but if you want to, go ahead. And then this is a function that um, basically creates a plot for you to plot on. So I wouldn't worry too much what this says. All this is saying is that in this first line, this is like basically creating like a place for um, like your data to be plotted on, and then this just removes um, like some like horizontal and vertical lines to make it a little prettier. So maybe let's do uh, let's do like SNS dot. Maybe do a distribution plot of the number of cholera cases, right? So if you SNS dot a distribution plot, and then we do maybe we'll do the cholera cases again. Copy this, put it in here. Oops, we have to run this. No module named Seaborn. Alrighty. Oh, I have to download it. Okay, 1 second, guys. Let me download it. Any questions while I'm installing it? Why is it not saying F Seaborn? Let me restart my kernel. Sorry, guys. 1 second. Alright, I guess since I can't run it, I guess I'll just show it to you. So I don't want to keep delaying. Um, okay, yeah. So I guess we'll use their data. So what you can do is you call this function, and this will um, create a plot for you to plot on, and then you do a histogram equal sns.distribution plot, and then now we're actually using salary data of the year since PhD. So you can see here, you can add distribution plot. It really is just a histogram, and then it tries to figure out distribution. It's pretty nice here. Um, you can also do something like a scatter plot. So yet again, we call the set PLT, and then we can maybe compare like year since PhD on the x-axis, and then salary on the y-axis. You notice here is that instead of like when I was doing it, you just give it the data itself. What you can do is that you can call reference to the data frame, and then you just give it the column names. So, yep. So you can see here we get a nice plot where you can see some type of you know positive correlation, and maybe it's um, quadratic. Maybe there's some line fitting right here. Yep. So that might be helpful if you're trying to do some type of analysis of salaries versus year since your PhD versus your salary. Okay, yeah. So yeah, if say you don't have Seaborn on your computer, which it looks like it's my problem, well, or it's the wrong version, you can go into your Anaconda terminal or Anaconda prompt, and then conda remove Seaborn, conda install Seaborn. Da, da, da. You may need to restart Anaconda. I don't, and that's how you do it. I don't want to. Reason I'm not doing that just because I don't want to stop and redo everything. So we'll just follow along with the instructor version for now. Um, and yeah, so you can see from this graph that like people who there's a lot of people who've been having PhDs for a while but don't get paid. What about how long they've worked? So if you see here, we're going to plot the years of service versus their salary. Yet again, we have that same kind of positive correlation that dips down. Same kind of like quadratic look almost to it, maybe not. Um, and we kind of see that, and then yeah, so same kind of trend going on, which is surprising. Um, yeah, okay, so now we're doing a different plot. So this plot, what we're doing is that we are going to be plotting on the x-axis the year since their PhD, the y is their salary, and then the color, which will be used by the hue of the dots, is their rank. So basically, like what position they hold, right? So we can kind of notice here is that like, hey, like if you've been probably less than 10 years at it since out of your PhD, you're probably gonna be assistant professor. If you've probably between like 10 and 20ish years, there's obviously some outliers out here. You're probably just an associate professor, and if you've been probably 15 plus, you're probably just a full-on professor. So that's another way. So you can color coordinate um, your dots on your scatter plot by using another column. Does anyone have any questions about this? All right, we'll keep moving on. So that's it for today. Um, this is a three-part series of Python. Today we learned about some variables, how to declare them, all that kind of stuff, functions, conditionals, graphing. Today we introduced like very like basic things, and obviously these can get a lot more complex, but I want to show kind of some of the power of Python. Um, Overall, we believe data science has the potential to revolutionize how we understand the world. Um, we think that data and data science can like change almost every industry and make things or make them have more informed decisions and more intelligence. As you see, like machine learning, AI evolve, data science will provide a essential part in it. And our goal is that we can give you the tools and the kind of guide you to help you maybe develop some of your skills yourself. So, um, thanks for everyone for joining. I really appreciate it. Um, and if you haven't already, please sign in and let us know that you came here tonight. It's in the description. A link's in the description. I really hope you guys sign up for or come to Python 1. And Python 1, I believe, will be going into more depth into these libraries and doing a little more complex analysis. Um, Today was just kind of the basics of Python. So thanks everyone for showing up. I'm going to stay on for like probably another 5 minutes and answer any questions if you have any. Doesn't have to be about the workshop. It can be about future events or data science as a field or anything like that. So thanks everyone for showing up. Appreciate it, and have a good evening. Bye. I'll also say that if you want to find us anymore, we have our GitHub up here. Our GitHub, is where we have a lot of our like workshops. So if you want to look at them before the hand, download them. Definitely recommend that. We also have our LinkedIn. Here we're going to try to post more stuff, keep you guys involved, and same thing on Facebook. So Facebook's probably our best form of communication. Um, Definitely, if you want to attend future events, definitely, so I think like add us to the group, and we'll keep you updated. So look forward to that.